Yes. Good evening. Good evening, everyone. How is everyone?
Fine, sir.
Fine, sir. Right. Okay. So let's start. We were in the mechanics part, na? Right. Yes, sir. So let's continue now. आप इधर बैठो, ठीक है? यहाँ बैठो. Okay. So let's start now. Right. So about the variation of what is acceleration due to gravity and what is the variation of how the acceleration due to gravity changes, isn't it? That is what we have discussed till last class, isn't it? Now, one more thing they can ask you in the question is the gravitational field due to the sphere. But again, when the sphere will be given, there will be two type of sphere given to you. Okay. Okay. Gravitational field on the axis of a ring we have written or disk. We can use the similar formula what we had for the electrostatic field. Na? Same formula we can write it for what? For the yes, gravitational field also. Okay. So let's discuss about the gravitational field due to a solid sphere and hollow sphere. Okay. And gravitational field is also called as what? The acceleration due to gravity. So gravitational field, okay, due to hollow sphere. Okay, hollow sphere means what? The mass will be only distributed where? The mass will be only distributed on the surface of the sphere. Okay. So again, we will have what? The 2 points will be there. One point will be what? Inside the sphere. Okay. And other point will be what? Outside the sphere. So just like the gravitational field when we have calculated, sorry, electrostatic field we have calculated due to hollow sphere. What was the field coming inside the hollow sphere? Was it coming zero? Please tell me. Field coming inside a hollow sphere. Was it coming zero? The same thing, gravitational field due to a hollow sphere, if I'm calculating, then there will be 2 points, okay? R less than or R less than capital R. R less than capital R means what? The point is an inside point. The gravitational field we are calculating inside a hollow sphere. Okay. So what is the gravitational field will come? The gravitational field will come 0. Okay. Next, if R is greater than or equal to R, that means if we are calculating the field outside the sphere, then what it will come? Then for outside point, whenever we have the spherical charge distribution or a spherical mass distribution, for outside point, what we can do it? We can consider like that entire mass of this sphere is what? Entire mass of this sphere is located at the center. So gravitational field for outside point, how much it will come? C m by r square, where m is what? Mass of the sphere is what? Mass of the sphere is capital M, and radius of a sphere is how much given in the question? Radius of a sphere is capital R. So that's why if you plot a graph of gravitational field versus distance from the center, okay? Gravitational field versus distance from the center. This is how the graph will look like. Sorry. Initially it will be what? Initially it will be 0, and after reaching the surface the value will decrease. Understood? This is due to what? Hollow sphere. If you want to calculate due to solid sphere, what will come? So gravitational field due to what? Due to solid sphere we are calculating. Okay. Solid sphere means what? Solid sphere means the mass is distributed. Okay. Solid sphere means what? Here the mass is what? Uniformly distributed. Okay. So again, we will calculate at what? We'll calculate at the 2 points, right or not? Here what we have? Mass of the solid sphere m and radius is r. So here density, what you will write it? Density we can write it m divided by 4 by 3 pi r cube. Understood? The density of the solid sphere, what we can write? M by 4 by 3 pi r cube we can write it. So now if you want to calculate the gravitational field for outside point, again the two important points are r less than r, and the second point what we have, r less than r means inside point. Okay, so what is the gravitational field inside will come? C M R by R cube. Can you see that? Is it similar result we got it for the electric field? Electric field when we were calculating, are we writing KQ is small r by R cube? Please tell me. So see, whatever the gravitational field formulas, sorry, electrostatic field formulas are there, na? Right? In that formula, if you replace this K, Coulomb's constant, by what? Gravitation constant. Next, replace charge by the mass. Okay. Then remaining all as it is, you can replace it. And all the electrostatic field formula will be converted into what? The gravitation field formula. So please tell me, understand what we discussed here? Please tell me. Please tell, for inside point, is it clear? And r greater than or equal to r, that means we that means we are calculating for what? The outside point. The outside point, if I calculate, then just as it is, just like a total mass kept at the center it is, that is how we will get the field. Okay. So again, if you plot the graph of gravitational field versus distance from the center, how the graph will look like? Right? Initially, it will be increasing. Center value will be what? Zero will be there. And after that, what? Of decreasing nature. So please tell me, clear about the gravitational field due to the hollow sphere and solid sphere? Please tell me. Please tell Charan and Lokesh, tell me, do you understand what we discussed till now? The
Yes, sir.
gravitational field calculation and its graph, isn't it? Gravitational field at the center, how much it will come? It will come as zero, it will come. Understood? Okay. So these are the things we have calculated. Now let's discuss some example now. Understood? Please tell me, clear? So now the question is what? A solid sphere is given to us, okay? In this example, what is given? A solid sphere is given to us. Now they are asking in the question, find find the distance from center of a solid sphere, solid sphere where gravitational field is, or gravitational field is half of the maximum value. Okay, half of the maximum value. Can you tell me what is the maximum value of gravitational field and where it will come? What is the maximum value of gravitational field due to a solid sphere? and where the value of the gravitational field as maximum comes? Does it come at the surface? Please tell me. This is what? Small r equal to capital R. That means this is the surface. What is the field at the surface? Field at the surface is Gm by R square, right? And if you look at the graph for inside point, the field is what? Directly proportional to R. And for outside point, the field is what? Inversely proportional to R square, right? So you see that when we go from center to the surface, the field increases. And again, from surface to outside, field decreases. That means on the surface of a planet or on the surface of a sphere, the gravitational field is what? Having maximum value. ऐसे चलाओ मत, okay? Okay, so gravitational field will have maximum value at the surface. Understood? So now we know the maximum value. How much is that? So tell me how many points will come where the field is half of the maximum value? Can you tell me how many answer will come for this question? One answer or two answer will come for this question? Please tell me. Two answer will come, right? What are the two answer? One point will be inside the sphere at some distance from the center, and one point will be outside the sphere at some distance, right? So let's calculate both of them and tell me how much is this coming. Solve this one. Very simple question is given. Please solve it and tell me how much is that coming. Okay, so what are those 2 points coming? Check it and tell me. What are those 2 points coming? So field inside, if I'm calculating inside point, if I'm calculating, so what I will write it? Field, I will write it ZMR by RQ. This is the field inside a solid sphere, isn't it? This is the field inside a solid sphere at a distance small r from the center. And how much this field I want? I want this field to become half of the maximum value. Maximum value is Zm by r square. So Zm by r, if you take it common, what are we getting here? Are we getting a small r equal to capital R by 2? Please check it. A small r equal to what? Capital R by 2. So it means when we will be at a distance r by 2 from the center, what will happen? The field will be what? Half of the maximum value. Now I'm going to calculate for outside point, okay? This calculation I have done for what? This calculation I have done for inside point. What point? Inside point. Now, for outside point, what should I write it? Should I write my field as Zm by r square? And again, that field I want is to be half into maximum value. Maximum value is Zm by r square. So that means if you simplify, what are you getting? Are you getting r equal to root 2r you are getting? Just check it. And both the distance, r by 2 distance and root 2r distance, both the distance is measured from where? From the center. Okay. So from the center, root 2r distance away from the center, root 2r distance away from the uh, center, again what will happen? The field is going to be half of maximum. So this is for what kind of point? For outside point. Understood? So these are the 2 points they ask in the question. where the field is going to be half of the maximum. Or you can also say that these are the 2 points where the field is equal also. Understood? Sometime in the question they will ask, right? What are the points where the field is what? Equal, right? What distance from the center, what depth from the what distance from the center, or what height from the surface, the field is going to be equal. Okay, so these are the, because this gravitational field is also called as acceleration due to gravity, na? Remember variation of g with height, right? As we go above, what happened? The gravitational field decreases. This exact result and approximate result. And at depth d, what happened? Cm by, and if you take it r square common, 1 minus d by r, it will come, na? So that means z at the surface into 1 minus d by r. Clear? So when we go above the surface of earth and below the surface of earth, again in both cases what happened? The gravitational field decreases. Okay, or gravitational field of a planet decreases as we go above the, कर दो ना ये, हाँ? So as we go above the surface of earth or below the surface of earth, both cases what happen? The gravitational field decreases from the value what we have it on the surface of earth. Understood? Please tell me. Clear this one? Please tell. Clear?
Yes.
Okay. So these are about the gravitational field. Okay, na? Gravitational field, gravitational field due to hollow sphere and solid sphere. Sometime let's discuss about the orbital motion also. Okay, or satellite motion also we can discuss about it. But to learn about the satellite motion, can I discuss a little bit about the gravitational potential energy? Just like electrostatic force. Okay, just today we will finish it about this gravitation, because again when we will discuss about the potential energy, we have to discuss about the gravitational potential energy separately. And we have learned the electrostatic potential energy, all these things, na? Just recently. So let's finish it about this gravitational potential energy also. Okay, energy conservation, right? We have applied now in the electrostatic many questions on the energy conservation. So here also energy conservation we can apply. Why? Because gravitation force is also what? Conservative force. So what will be the gravitational potential energy? So gravitational potential energy means what? Again, it is the interaction energy between what? The two particles. Okay, let's say there is one particle M1, there is another particle M2, and the separation between them is something R. So what will be gravitational potential energy between them? Minus Z M1 M2 by R. That is called the gravitational potential energy between the two particles. Okay, this is the gravitational potential energy of the two particles. Understood? Is that clear? So whenever we have to calculate the gravitational potential energy of a number of particle, what we should do it? Should we add all of them? Understood? What we should do? We should add all of them, isn't it? Sometime they will ask you a question, something like this. Initially, these charged particles were what? At a triangle of masses is given what? M, M, and M. Okay, and the side of this triangle is what given? Side of the triangle is given as A. Equilateral triangle given to us in the question, whose side is given as A. Now the question is saying that uh, now they will try to attract each other. Now, so what we are doing, let's say we want to increase the side of the triangle. Understood? and slowly they are still maintain the triangular shape, this frame, but now what is happening? Now the side of the triangle has become how much? 2a, 2a
Sir,
it has become.
hello.
So yeah, yeah, tell me.
Can you share the notes of previous classes in WhatsApp group?
I already shared, na?
Till Newton's laws of motion.
It's already shared in the group, right?
We had last class on 7th, I guess.
Yeah, this one, na?
No, this is no gravitation. We haven't started. You didn't share friction. We did.
Yeah, gravitation part, na?
You didn't share
This
gravitation.
one, na? This one.
Yes, sir. Yes.
From this page, na? Don't
Sir,
worry.
don't we
Today,
have rotation?
haha.
We don't we have rotational mechanics?
Yes, we have, na?
Then why are we starting gravitation?
No, we are in NLM. NLM, the gravitation was given in detail. Uh, just check it once. So that's why we
Okay.
discussed about all these gravitational field, acceleration due to gravity, its variation. Okay, na? And
Okay,
this
sir.
part is a little bit extra. I'm discussing what just now I entered. Okay, na?
Okay, sir.
This part. Gravitational potential energy is not given in your NLM chapter, but actually, we have discussed the gravitational potential energy, electrostatic potential energy, its conservation, many questions in the electrostatics. So
Yes, sir.
that's why we are discussing this gravitational potential energy part also. Okay.
So, sir, after gravitation, we'll start rotation, circular motion.
Yes, circular motion.
Okay, sir. Okay.
Right. Okay. So this page I will share with you. Don't worry. Okay. Now, last class I think I forget to. Last week we didn't have any mechanics class, na?
Yes, sir.
I will share it. Okay. So now in the question, what they are asking, initially the side of the triangle is A, and we have pulled it apart, है ना? So that now the side of the triangle has become 2A. So they are asking in the question, find work done by external agent. Okay. Find work done by external agent in changing the configuration. Okay. In changing the configuration. Changing the configuration means what? Changing the configuration from A side to A side. Okay. What is the work has been done by external agent? That is what they are asking. And it has been pulled slowly apart. Slowly apart means what? There is no change in kinetic energy happening. So whenever there is no change in kinetic energy, can you tell me what is the work done by external agent then? If change in kinetic energy is zero, if change in kinetic energy is zero, then can we write it work done by external agent equal to change in potential energy of the system? The work done by external agent equal to change in potential energy. It can be only written if there is no change in kinetic energy happen. मतलब if this process is completed very slowly, na, then work done by external agent we can write it as what? Change in potential energy of the system. So now tell me what is going to be U initial? Is the U initial is going to be minus C M1 M2 by A, and like that how many pairs are there? Tell me. One pair, right? Another pair, and these two. Again one more pair. And do you see that all these three pairs are exactly same? So should I multiply it by 3? So that is your initial potential energy. What is your final potential energy of the system? Minus Z M1 M2 by 2A, because now the side has become 2A now. So what is going to be the work done by external agent then? Work done by external agent, we can write it change in potential energy means U final minus U initial. So that means how much is that we are getting? Just check it once. We can take common, right? If we take common G M m by a, or 3 gmm by a if I take it common. So u final is minus 1 by 2 minus u initial minus 1 will come, right? 1 minus 1 by 2. So we are getting 3 by 2 gmm by a. So that is what the work done by external agent in increasing the separation between these particles. Understood? So this energy conservation, work energy theorem, all these things will be what applicable as it is what you have done it in what you have done it in the electrostatics question. Exactly same way we can apply it here. Okay, as we have applied these concepts in the electrostatics, exactly same way we can apply it here as well. Please tell me, clear up to this? Please tell me,
Yes.
clear? Right.
Yes,
So,
sir.
okay. So this is what we have discussed. Now let's discuss another thing. A gravitational potential energy is what? It is between the two particles. We have calculated what will be the gravitational potential energy. Again, we can define the same way what is going to be the gravitation potential. Then potential multiplied by the mass, it becomes what? The potential energy. Understood? So all those steps of electrostatics, electrostatics and gravitation are almost similar. 70-80% part of the gravitation is exactly same as we have discussed in the electrostatic. Okay, only symbols are different. That's it. Okay, clear? So now just okay, again circular orbital motion we have to discuss about the circular motion, isn't it? Right. So chaliye, let's start now today with the circular motion part. Okay, right? So gravitational potential energy understood. And what will be gravitational potential? Can we say that gravitational potential is going to be potential energy per unit mass? Gravitation potential will be how much? Gravitational potential energy per unit mass. We can call it as the gravitational potential. Understood? Please tell me. Up to this part is clear? Please tell me. Clear up to this? Okay. Let's start with the circular motion. Okay. So in the circular motion, what kind of motion is that? The circular motion. Why we are discussing especially because in the circular motion, here the path of the particle is what? The path of particle is circle. Means the particle is moving along what? A circular path. Okay. In a circular motion, the particle is always moving along what? Along a circular path. Let's say the radius of circular path is something r. Okay. So in a circular motion, can we say that particle velocity will be always changing? Can I say that in a circular motion, the particle velocity will be what? It will be always changing. It's not possible to keep the velocity constant. But we can keep what constant? We can keep the speed constant. Understood? Speed and velocity are two different things, isn't it? So in a circular motion, it is possible to have what? Speed constant type of circular motion. But if you say in a circular motion, the velocity is constant, that is never possible to keep what? The velocity to be what? Constant in a circular motion. So in a circular motion, only the speed can be kept constant. Is that clear? So in a circular motion, there are some variables. Let's call this line as what? The reference line. Okay. A reference line. Let's say a particle is starting from some point here and it has moved some distance here. So can I say that it has traveled some angle theta? Please tell me. It has traveled, it has moved along the arc of the circle, isn't it? Along the circumference of the circle. So can I also say that this particle has covered, let's say, point A to point B, the particle has covered some angle. So what is this theta called as? This theta is called as, can you tell me what is this theta called as? This theta is called as the angular displacement. What is this theta called as? This theta is called as the angular displacement. Understood? What is the theta we have here? Theta we have it here is the angular displacement, right? Now, the next thing, if the particle is already covered this theta angle, it must have taken some time to cover the theta angle, isn't it? Please tell me. The particle must have taken some time to cover this theta angle from A to B. So this angular displacement divided by time taken to cover that angular displacement, what will be that called as? That will be called as the angular velocity. Understood? So what is the angular velocity? In the average term, what I can write it? Delta theta by delta t, we can call it average angular velocity. And in case of instantaneous, we want to write it. So what we will write it? D theta by dt. And instantaneous means a small interval of time, and that is represented by what? Omega. What is this omega called as? Omega is called as the angular velocity. Okay, what is the omega called as? Omega is called as the angular velocity. Angular velocity means how much angle the particle is covering in a unit time. That's why it is called what? The angular velocity. Understood the second part? Now the third thing, अब sometime in the question omega matlab angular velocity will be also changing in the path, isn't it? Or in the journey. So what is this d omega by dt tells us? That is written as alpha. Alpha is called as what? The angular acceleration. So whatever the linear variables we had na, when the particle was doing the linear motion, then we have focused in what variable? Linear variable. Now the particle is doing circular motion. So all those linear variables, what we did, we have converted all those linear variables into angular variables. Understood? So understood up to this? Clear? So this is called the angular acceleration. Now, once we understand that one, the angular displacement, what will be unit of angular displacement? Can you tell me what will be unit? Unit is going to be radian. Angular velocity unit, radian per second. And angular acceleration unit, radian per second square. But many time you will see the unit used as what? RPM, revolution per minute. But in one revolution, particle will cover how much angle? One complete revolution, particle will cover how much angle? 360 degree or 2 pi radian. Okay, so please keep in mind whenever the answer is given or asked in what, in the SI unit, then what we will do, we will use the unit of angular displacement, angular velocity, or angular acceleration as radian, radian per second square. Is that clear? Now there is a relation between what? A relation between linear and angular variable. Okay, what is the relation between linear and angular variable? Okay, relation between linear and angular variable. What does it mean? It means what? How the when the particle is moving on a circular path, then we have defined some variables called the angular variable, right? And particle actually moving what? Particle actually moving along the tangent, isn't it? So let's say here initially the particle is here, and after some time it has covered some d theta distance, it has covered from A to something A dash. So if I ask you what is the angular displacement, can you answer it? What will be the angular displacement? Please tell me, what will be angular displacement of the particle from A to A dash? It will be d theta, hai na? The small angle theta it has covered, isn't it? So linear displacement will, angular displacement will be d theta. And if I ask you, what is linear displacement? Matlab, along the tangent, how much it has moved? So can you write it? This along the tangent, let's call it A, let's call it S. S is the tangential, how much it has moved. And d theta means what? How much angle it has covered. So can I say that A dash is going to be R into d theta? Or let me call it as something ds, है ना? Can we call it? ds is a small, so ds equal to what? Linear displacement. D theta is called as angular displacement. And how are they related? They are related as linear displacement is equal to arc length. Arc length equal to r into d theta, where r is what? R is the radius of the circular path. Now, if I divide it by dt both the side, what is my expression will become? Will it become ds by dt? What is ds by dt? ds by dt means, does it mean by ds by dt that it has traveled that small ds distance along the circular arc in how much time? In the dt time. Can I call this velocity as linear velocity, or we can also call that as the tangential velocity? And what is d theta by dt? D theta by dt is angular velocity. So can I say v tangential will be equal to r into omega? So tangential velocity, can we write it? It is going to be r into omega. Can we differentiate one more time? D by dt of this tangential velocity, how much it will come? D by dt of r into omega. D by dt of tangential velocity, will it become the tangential acceleration? Radius of the circle outside d omega by dt is alpha. So understand the relation between the linear and angular variable. Here ds is linear displacement, d theta is angular displacement, vt is linear velocity, which is also called as tangential velocity, right? And at is called the tangential acceleration. So these are the relation between what? Linear and angular variable. Understood? Once you understand that one, please tell me, clear up to this?
Yes, sir.
Okay. So what are the equations we have written now? In the linear motion, equation of motion, three equation of motion. Do you remember three equation of motion? S equal to ut plus half at square, v equal to u plus at, and v square minus u square equal to 2s. So we have written three equation of motion for linear displacement. You know, all these three equation you can apply for angular displacement also, okay? But what is the condition needed there? There the condition was that acceleration should be constant. Linear acceleration should be constant. Here what is the condition needed? If the particle is doing circular motion and its angular acceleration is constant, then I can apply the equation of motion. So what is equation of motion? Okay, for circular motion. Okay, What are the equation of motion? We have the circular motion. Again, the condition is what? The alpha should be what? Constant. Okay, so what equations we can apply it? Theta equal to omega initial into t plus half alpha into t square. Understood the first equation? Second one, omega after some time, let's call it omega final. Can we write it omega initial plus alpha into t? Second equation. Again, keep in mind about the direction, right? Like when you were writing the displacement velocity thing, you were considering the direction, that whether you want to write towards right as positive or left as positive. Same way here also, you must consider the direction when you are going to use these equation. Okay, and one more is what? Omega final squared minus omega initial square equal to 2 alpha theta. So these are the three equation of motion we have. For what kind of motion? For circular motion. Understood? Let's discuss one two example on that. Okay, and then we will discuss the type of circular motion. Okay, let's discuss a simple question. If fan is switched on, and it start it starts rotating with uniform acceleration, है ना? With uniform acceleration. Okay, question gave that when the fan is switched on, it starts rotating with what? Rotating with uniform angular acceleration, because the motion will be what? The circular, you can say that every point of the blade will be what? Doing what kind of motion? The circular motion. Okay, na? The fan is switched on and it starts rotating with uniform acceleration of 5 radian per second square. Okay, find first thing velocity. Which velocity? Angular velocity, है ना? Find first thing angular velocity, okay, at the end of 4 second. And the second thing, number of revolution completed by fan in the 4 second. Okay, do you understand the? Tell me, please tell me, understood the question?
Yes, sir.
Please tell me, understood the question? Simple only, na? Fan is switched on, right? The moment you will switch on the fan, it will start accelerating, right? So they are asking in the question, what is the angular velocity of the fan after how much second? 4 second. And it's given uniform acceleration. So uniform acceleration means what? All the three equations we have written, that is valid, isn't it? And the second thing, number of revolution completed by the fan in the 4 second, first 4 second interval, how much revolution the fan has completed. So please tell me how much is that coming? Please tell me how much is this coming? Try it. It's a simple only, na? Not a very difficult question. Please tell me. It's a simple equation. We need to apply it here. Second one is number of revolution completed by fan in 4 seconds. Okay. So calculate the angular displacement. You will get it in the radian. Convert the radian into revolution. So how do you convert revolution into radian? So to complete convert convert revolution into radian, you multiply by 2 pi. So radian into revolution, you will divide it by 2 pi, isn't it? Please tell me. So please use that one and tell me how much is this coming. Please tell me how much is this coming. Got it? This one or not? Angular velocity at the end of 4 seconds. So we can simply use it omega final equal to omega initial plus alpha into t. Finally, omega they are asking in the question, starting from rest. Alpha is given 5 and time is 4. So what is the final angular velocity? 20 radian per second we have. Number of revolution completed by the fan in 4 seconds. The number of revolution, if I want to calculate, should I use it? Theta equal to omega initial into t plus half alpha into t square. Initial omega 0, right? Plus half. Alpha is 5, t is what? 4 second squared. So 16 into 5, 80 by 2, 40 radian we got it. Is it my answer of the second question? Is it the number of revolution I have calculated, or did I calculate just the angular displacement of the particle or the fan? Listen me. We have now calculated only the angular displacement, not the number of revolution. So how do we convert it? The simple conversion is what? One revolution. One revolution is equal to how much? 2 pi radian. Means if something complete one full cycle, one revolution, then it covers how much angle? It covers the 2 pi angle. So that's why one revolution is 2 pi radian. Please keep in mind this conversion. Okay. So can we write this question for answer further? 40 radian. So 40 into, and 1 radian means 1 by 2 pi revolution. Can I write it? Understood? So 20 by pi revolution, you can say that. Revolution short form, you can write it REV. Okay. So simple questions you will get it in the these kind of if the uniform acceleration is given as uniform. Okay. Interesting questions will come if it is non-uniform. Then we have to take help of what? The integration in solving the question. Okay. Tell me, clear? So the next thing, type of circular motion, let's try to understand. Okay. There are two type of circular motion. Okay. There are what? Two type of circular motion. Okay. What are the two type of circular motion? One is called uniform circular motion. Okay. And the second one is called what? Non-uniform circular motion. Can you tell me the difference between these two? What is the difference between uniform and non-uniform circular motion? Please tell me, what is the difference between uniform and non-uniform where speed of the particle remain constant? And non-uniform circular motion, what will happen? The speed will change. Understood? You will be saying, sir, why didn't you write velocity constant or velocity changing? Because in a circular motion, velocity can never become constant. Understand why? Because whenever a circular motion will happen, isn't it the direction of velocity of the particle will be always changing? So even though magnitude of velocity is not changing, but only due to change in what direction we can say the velocity changing. So that's why circular motion cannot be of constant velocity. If it is a circular motion, either speed will be constant or speed will be variable. Velocity will be never constant. Okay. So now let's try to understand in detail what is the uniform circular motion. Okay. So in uniform circular motion, what did we learn? We learned that the speed is what? The speed is constant. है ना? Is it this what we have learned in the uniform circular motion? Speed constant means what? Velocity constant? No. Velocity constant means speed constant? Yes. But speed constant means velocity constant? No. Understood? So here what is constant? Speed is constant. So if speed is constant, if it is going to do the circular motion speed, tell me what is going to happen. In a circular motion, we have two type of acceleration. One acceleration is called tangential acceleration, which we have written a d omega by dt. One more acceleration of circular motion is called centripetal acceleration. Okay. One more acceleration of the particle is called what? Centripetal acceleration. So what is the purpose of tangential and what is the purpose of centripetal acceleration? Let's say if particle is here, so this particle can have the chance of having two type of acceleration, tangential as well as centripetal. Tangential means what? The component of acceleration which is responsible for speed change. Here speed is a constant. Here speed is a constant. So what acceleration will be zero? A tangential, which is also equal to r alpha, that is going to be zero. But is that means that the total acceleration is zero? No. There is one more acceleration that is called centripetal acceleration. And how much is that? V square by R, and V is equal to R omega also. So omega square into R. So please keep in mind in any type of circular motion, whether it is a uniform or non-uniform. Uniform means speed constant. What will happen? Tangential acceleration will be zero. Okay. In a uniform circular motion, what will happen? Tangential acceleration will be zero, but centripetal acceleration is still going to be there. What does it mean by tangential and centripetal? Tangential means along the tangent, centripetal means along the center, towards the center. Understood? So in a uniform circular motion, what happens? Which component of acceleration is zero? Tangential is zero, or r alpha is zero, but the centripetal acceleration, it is still there. Okay. So let's say if this particle had the velocity something v like this, can I call this acceleration as ac? So in uniform circular motion, can I say net acceleration will be only the centripetal acceleration? Please tell me. In a uniform circular motion, the only acceleration the particle will have is going to be the centripetal acceleration. And how much is that? It can be written as v square by r, or it can be also written as omega square into r. So we have to discuss some examples on this topic now. Okay, uniform and non-uniform circular motion. Okay, so please tell me, everything clear what we discussed till now?
Yes, sir.
Please tell me, clear up to this what we have discussed?
Yes, sir.
All of you will be free tomorrow, same time, because Wednesday I have to go outside. Some work is there. So I am thinking that Wednesday class we can have it on yesterday, tomorrow itself. All of you are free at 8 p.m.
Yes,
12.
sir. Sir,
Yes, sir.
Tell me, Lokesh.
Free, sir. Free, sir.
which timing, sir? What can you repeat?
Yeah, exact same time, 8 to 9.
Okay,
Just
tomorrow
Wednesday class
evening.
I want. Yes, yes. Wednesday we have the class. Tomorrow we don't have the class. So I just want to prepone that Wednesday class to yesterday. Sorry,
Okay,
tomorrow. So
okay,
that
sir.
Wednesday I will be free. I have to go outside. Some work is there. Okay. So let's have it
Yes, sir.
tomorrow
Okay,
then.
sir.
Tomorrow 8 we will have this class. Okay. Again.
Yes, sir.
Right, everyone. Okay. So let's meet it tomorrow. I will share the notes. Okay. After one more class is there.
Okay,
So
sir.
after that I will share.